Hey everyone, welcome to this explainer. I'm your host, and today we're going to figure this out together and totally demystify linear inequalities so you can confidently crush your upcoming math exam. If you've ever stared at a greater than or less than sign and felt a sudden wave of panic about whether to flip it or leave it alone, you are exactly in the right place. Think of me as your virtual tutor. We're going to strip away the confusion, rely entirely on structured visuals, and build your confidence step by step. Here's our playbook for today. We'll start with intervals and inequality basics, tackle the negative sign flip, solve some common practice problems, and finally, conquer overlapping interval ranges. All right, Section 1, Intervals and Inequality Basics. Let's get our core building blocks in place before we dive into the algebra. So, what's the big fundamental difference between what you already know and what we're learning today? Well, an equation like x equals 5 is super specific. It's a closed case, right? Exactly one solution. But an inequation, or inequality, like x is greater than 5, that blows the doors completely open. We're not looking for one single answer anymore. We're looking at an infinite number of solutions. 5.1, 6, 100, a million, they all work. Grasping that we're dealing with infinite possibilities is absolutely crucial for everything else we're going to do. Now, since we have infinite solutions, we obviously can't just write down a single number as our answer. We've got to map out a range, and we use intervals for this. Think of open brackets or parentheses like a fence that doesn't quite touch the exact number. You use them when the extreme number isn't included, like if x is strictly greater than 2. But if x is greater than or equal to 2, we bring in the closed square brackets. That square bracket is basically telling your examiner, hey, this exact number is officially part of my solution set. Moving right along to Section 2, the negative sign flip. Let's logically tackle the absolute golden rule of inequalities. Examiners absolutely love testing this. It's a classic trick. What exactly happens to that little greater than or less than sign when you multiply or divide both sides by a negative constant? A lot of students just blindly memorize the rule. But you know what? When exam pressure hits, memory fades. So let's actually prove why this happens so you literally never forget it. Let's look at a logical proof that shows exactly why that sign has to flip. Start with a totally true fact. 3 is greater than 2. Easy, right? Now let's multiply both sides by -1. If we stubbornly refuse to flip the sign, our statement becomes -3 is greater than -2. But wait a second, picture a number line. -3 is further to the left. It's mathematically smaller than -2. So that statement is completely false. To fix reality and keep the math true, we are absolutely forced to flip the sign around. -3 is less than -2. That right there is the visual proof you can always fall back on. Okay, Section 3, solving common practice problems. Time to put all this theory into action, step by step. Here's a super common exam question. We need to algebraically isolate x to find all the values that make this statement true. 7x minus 9 is less than 12. Let's break this down. You really just treat it like a normal equation to start. First up, we shift that minus 9 to the other side by adding 9 to both sides. That gives us 7x is less than 21. Next, we want x all by itself, so we divide by 7. Now pause right here. Ask yourself, is 7 positive or negative? It's positive, so crucially the inequality sign stays exactly the same. Our final answer? X is less than 3. But here's the catch. Your final written answer completely depends on the constraints given in the specific question. If the exam asks for real numbers, you write an interval, open bracket -∞ to 3, with another open bracket because, remember, 3 isn't included. But what if they ask for integers? Well, then your answer is a set of specific whole numbers, ... -1, 0, 1, and 2. And if they ask for natural numbers, those start at 1, so your only valid answers are exactly the set of 1 and 2. Please always read the question carefully to see exactly what kind of numbers they want. Let's level up a bit. Here's a trickier practice problem where we've got variables on both sides of the inequality. 4x minus 10 is less than or equal to 6x minus 12. Our first job here is grouping. Move the 6x to the left and the -10 to the right. Simplify that down, and we get -2x is less than or equal to -2. Okay, alarm bells should be ringing. To isolate x, we have to divide both sides by -2. And this is where we apply our golden rule. Because we're dividing by a negative, we literally have to flip that less than or equal to sign completely around. It becomes greater than or equal to, giving us a final correct answer of x is greater than or equal to +1. Finally, Section 4, Overlapping Interval Ranges. It is boss level time. We're going to tackle multiple inequalities at the exact same time. In these more complex scenarios, the examiner gives you a whole system of inequalities. Basically, we have to act as mathematical detectives. We're looking for the common ground that makes both statements happy simultaneously. For an answer to be correct, it has to satisfy both rules. What's really cool here is how we solve the two systems side by side. On the left, we simplify everything down to get negative x is greater than negative 3, which, after our trusty negative sign flip, becomes x is less than 3. Then, over on the right, we simplify to negative 4x is less than 4, which flips to become x is greater than negative 1. So we've revealed two distinct conditions. X must be strictly less than 3, and at the exact same time, x must be strictly greater than negative 1. Now, trying to hold both of those rules in your head, absolute recipe for disaster. To avoid simple mistakes, I highly recommend physically drawing a relative number line right on your scratch paper. It really helps visually anchor these abstract overlapping ranges. So you plot your negative 1 and you plot your positive 3. Draw an open circle at negative 1 and shoot an arrow to the right. Then draw an open circle at 3 and shoot an arrow to the left. By finding that visual overlap, the exact zone where those two imaginary arrows cross over each other, we can confidently say that the only valid answers are the numbers sitting strictly between negative 1 and positive 3. Written as an interval, that's simply open bracket, negative 1, comma 3, open bracket. But watch out, because examiners love to throw in trick questions where the two ranges point completely away from each other. Imagine you solve the equations and end up with x is less than or equal to 0.25 and x is greater than 0.75. If you draw that out on your number line, the arrows are running in opposite directions. There is absolutely zero common ground. When that happens, don't panic. Just proudly write no solution as your final answer. As your virtual tutor, I really want to emphasize that solving these inequalities is like building a muscle. The rules we covered today, especially that negative sign flip and the number line trick, those are your solid foundation. But practicing these steps over and over, that's the only way you're going to build unstoppable exam confidence. So now that you've got the playbook for decoding linear inequalities, what mathematical mysteries are you going to unravel next? Because here's a secret. Once you master these overlapping intervals, those terrifying multi-paragraph word problems, they're honestly just these exact same algebraic rules hiding in plain sight. Keep practicing, trust your visual methods, and you are absolutely going to crush that exam. Thanks for joining me on this explainer, and I'll see you next time.